Let's have a look at this thing called the point slope formula. One of the more useful formulas we have, certainly when we're talking about the equation of lines. There it is. Y minus y1 is m outside of x minus x1. If you think about it, really it is just the slope formula. Just rearranged. Yeah, y2 minus y1 over x2 minus x1. We move the multiply by the x2 minus x1. So that's all it really is. But with this formula, we should be able to find the equation of any line. So here's a typical sort of question. There is, in some textbooks, I don't know which one you used last year, they have this thing called a 2-point formula. Have you ever seen that? Yeah. I think it's a waste of time myself, because you already know the formula for slope. So let's just find the slope using that formula, -2. Now we have a point, well in fact we've got 2 points, and we've got a slope. Doesn't matter which point we use. I use the first one, so y minus 4, -2 outside of x plus 3. And there's our answer in general form. It just saves me having to memorise yet another formula. Let's look at this example. Equation of line passing through 2, -3, parallel to 3x plus 4y minus 5. So we see a question like this. Equation of a line. I need two things. What are those two things? A point and a slope. We have a point. Yes. A slope. Oh, damn. However, there must be more information in there that will allow us to find the slope. That other piece of information is, of course,
parallel.
Parallel. How's that going to help me?
Same slope.
Okay, so we got 3x plus 4y minus 5 equals 0. Slope of that, I'll just rearrange it, there you go, minus 3/4. So we know it's going to have the same slope. We want to use minus 3/4. We have a point. We have a slope. Point slope formula. Play around with that, and there's our answer in general form. Now, this brings us to a quicker way of doing this sort of question. Have a look at my answer, and have a look at the equation of the line that was parallel to. What do you notice?
The same except the last.
Ah. The coefficients of the x and the y are the same. Has to be. Because if you were to work out the slope, you'd go y equals mx plus b, you'd rearrange it, those coefficients would form the slope. So knowing that, what I could have said was, well, if it's parallel to 3x plus 4y minus 5, then it must be in the form 3x plus 4y plus something equals 0. I just got to work out what that thing is. Well, we know a point on the line, 2, -3, so if I just substitute that point in, I can work out what the k is. The k is 6. And there's the equation of our line. All right, we can do a similar thing with perpendicular. Find the equation of the line passing through, but this time it's perpendicular. So the same sort of question. I need two things. I need a point, I need a slope. I've got a point, I haven't got a slope. But there must be some information there that allows me to find the slope. That information is perpendicular. So what's that mean for this one? All right, well, let's find that slope. Well, 9 on 4 is the slope of the line they gave me. So therefore, minus 4 on 9 is the one I want. Okay? Point slope formula. Okay. Let's use that same idea, because we're still talking about a relationship between the slopes. Have a look at the answer. Have a look at the original question. What do you notice? They've flipped. Something else has happened though. And the sign in between them has changed. Okay? Now I suppose that's one advantage of always making sure general form the coefficient of x is positive. Because then that pattern will always happen. We'll just swap and then flip the sign in between the x and the y. So knowing that, what I could have done is I could have said, this one's 9x minus 4y, so my one will be 4x plus 9y. Again, I've got a point on the line, I can substitute that in and work out k. And we get our line. Okay. If I have to go and prove three lines are concurrent, what does concurrent mean? They all go through the same point. Concurrent. So, how would we do it? Well, I've got 3 lines. What I would do is I'd pick a pair, solve them simultaneously. That'll get me a point of intersection. Now, if that point of intersection also lies on the line that I did not use, then all 3 must go through that point. So that's how I would do it. I think that's the quickest way to prove concurrency. Okay.